Welcome back to Computer Graphics and Visualization subject. We are discussing Module 1. In this module already we have discussed raster scan and random scan devices, right? Before that we have discussed applications. All the concepts we have discussed. Today we are discussing the raster scan system, right? Raster scan system we will discuss. First, don't get confused, raster scan devices and raster scan system. Raster scan device means we have discussed only monitor part of those devices. We have discussed only other end, means that is a monitor display device we have discussed. Here we are discussing the system. System means at a processor side what happens, how that will convert that your geometric image input to the pixels. That part we are discussing here. Again, that's why I am telling, don't get confused. What is the difference between device and system? Device is only monitor side we have discussed, how the monitor works, right? That part. In random and raster scan devices we have discussed only monitor part. In this raster scan system we are discussing at the processor side what happens, how that input will be converted to digital format, then how that will be displayed, right? That part we are discussing in raster scan system, right? As you may be knowing, in addition to the central processor unit CPU, most of today's devices, right, especially laptops, desktops, one special purpose processor you are getting, that basically called GPU, graphics processor unit, graphics processing unit. Again, that graphics processing unit has again subparts, that is a video controller, right, or display controller, right? This means nowadays CPU is not sufficient to do work in our systems. It may be desktop or it may be laptop, because everybody now, other than academics, we are using our system for the entertainment, right? Once entertainment comes, then you may be playing game, right? In very first class we have discussed that again game is application of computer graphics. Gaming is application of computer graphics. Once computer graphics application comes, our CPU must do many tasks. CPU has to do many tasks. That's why if only CPU is available in your system, the automatically speed of your system will be reduced, because other than CPU normal work means managing operating system, file system, or input output devices regularly CPU does, right? Then other than that, again if you assign heavy workload with related to computer graphics operations, that's why work will be heavily loaded in CPU. To reduce the work or burden on the CPU, today recent systems devices will come with a special purpose processor called video controller or display controller. Along with that, again GPU, that is graphics processor. In combined together, display controller, video controller, right? Combined together we will call it GPU, graphics processing unit, is used to control the operation of the display device, right? Again one more exclusive processor is coming, that is a video controller or display controller. Only it is used for controlling the operations of a display device. It is doing nothing, just it controls the operation on a display device, means how to display on a monitor. For example, if you are using a CRT or if you are using a flat panel or whatever monitor, how to take content from the where it may be available in the frame buffer, from frame buffer how to display it in a monitor. Only this processor takes care of this. Display processor only takes care of how to display the output of graphics, which may be available in memory, From that memory to display, how to display, that will be taken care by video controller, right? Means nothing but by inserting one more additional processor, that video processor, you are reduce the burden from the CPU. Otherwise, who has to do if video controller is not there? In olden days processor, there was no video controller. At that time, everything will be done by CPU. That time CPU was heavily loaded. Once CPU is heavily loaded, then your speed will be reduced, right? That's why video controller does that one. That is, a fixed area of system memory is reserved for the frame buffer. As you know, already in last class I have told that there is exclusive memory we are going to reserve for storing the output of your graphics application. Graphics application output already we are storing it at frame buffer. From frame buffer we have to take the content of the frame buffer, then just we have to display it in our device, that our monitor. right? That is our monitor. That's why exclusive memory is available. As I told, frame buffer is nothing but a memory. Memory here exclusively you are reserving memory for frame buffer, and the video controller is given direct access to the frame buffer memory. Now that's why I told here, only what video controller does, already your output of your computer graphics application is available in frame buffer. Already output of your application is available in frame buffer. Only now what we have to do, that output we have to take, then as per that output I have to display it in my monitor. That has to display in our monitor. That is available in the memory. Still it is not displayed on your monitor. Then there may be somebody has to take the output from this frame buffer, then he has to draw here. That has to be drawn, right? Who is going to do? That is a video controller. Video controller, display controller. He is going to do. That's why video controller has a given direct access to the frame buffer. The input to the video buffer is nothing but directly output from the frame buffer. Whatever available in the frame buffer, it goes to frame buffer memory location, takes the content. For example, 100 means 100 to 100. Frame buffer memory location is 100 to 100. Then goes to 100 memory location, 0 to 100. Assume that your frame buffer memory is 0 to 100. It goes to 0th memory location, takes the content. Then respectively, as again I have told, frame buffer size is exactly equal to number of pixels on your monitor. If there are 100 pixels on your monitor, then frame buffer size must be 100 memory locations, because every pixel in your monitor corresponds to one memory location in a frame buffer. That's why 0th pixel in your monitor may be mapped to 0th memory location. Example, just I am telling an example. It is not always 0th memory location or all those things. That depends on the CPU, right? Assuming 0th memory location to 100th memory location you are reserved frame buffer, then 0th memory location corresponds to 00 pixel, next, like this. That's why directly for video controller accesses the frame buffer, then takes the content from the frame buffer, then it starts displaying. Again, how it displays, as I told, raster scan goes line by line. Means it starts here, comes left, comes right, goes left, comes right, like this it does, right? Then in operations performed, refreshing operation, then transformation. Operation performed by this is refreshing operation, then transformation. Transformation is nothing but areas of this screen can be enlarged, reduced or moved during the refresh cycle, right? Normally if something is displayed on your monitor, normally what user does, by taking the mouse he may drag and drop in different. I assume that first you have displayed your square somewhere here, you have displayed your square somewhere here, then normally afterwards what you will do, you will hold that square, then you may drag and drop somewhere here. At that time again means what you have done, already you have drawn that somewhere here, again your drag and drop means nothing but what is that, what my process has to do, redraw here. It has to redraw this one with a different place, in different place, right? That's why there is a transformation. That who will do, that display device, display controller has to do this one, right? The refreshing operation, right? As I told, what do we mean by refreshing, right? Then this is the system, right? CPU will be there normally. CPU is a general purpose processor which takes care of your operating system management, right? File management, process management, input output managements, all managements will be taken care by this. Then peripheral devices will be there. Then as I told, so this is a memory. If you want, you can reserve exclusive memory for a frame buffer, or some part of system memory is reserved for frame buffer, right? Again, there are different type of frame buffers are available. Means exclusively one memory you buy and reserve it for a frame buffer, or some portion of your system memory itself can be reserved for frame buffer. Then video controller has a direct access to this. Video controller directly takes input from the frame buffer, then displays on monitor, right? This is a system bus. This is the architecture of our normally graphic system, today's graphic system, right? Then the basic refresh operation of the video controller, as I told, it does the refreshing. Means basic operation of the video controller. First it has to do the refresh in the sense, as I told, means if you have CRT monitor, then we are using phosphor. At the monitor side we are using phosphor. Then phosphor property is only it emits light for a shorter duration of time. It is emitting light wherever you are striking, wherever electron strikes on that particular pixel, that part of the phosphor emits light for only shorter period of time. But what happens, assume that in last class, in last video I given example, assume that it has only life 5 seconds. It has only that light emitting life is only 5 seconds. You have struck one pixel, then it has started glowing. How much time it glows? Only 5 seconds, right? After 5 seconds automatically it goes off. After 5 seconds automatically it goes off. Unfortunately, if you don't see the pixel within the 5 seconds, then what you will feel? That pixel has not glowed, because you have seen after 5 seconds. Actually that pixel has glowed, that pixel has emitted light, but what has happened? You have seen that pixel after 5 seconds, right? Because of that you are telling that pixel has not glowed, because the lifetime of that pixel light emitting is only 5 seconds. That's why if you want to see for a longer time, if you want to see that particular pixel is glowing for longer time, then before 5 seconds one more time you have to strike that, one more time you have to emit the light on that area, right? Then only again from that point, again from that time, again 5 seconds, like that continuously. If you want to see any object, any image on your monitor, then before that pixel goes vanishing, means light goes off, you have to continuously keep on striking, you have to keep on glowing. That is what refresh, right? Every pixel has to be redrawn every time again as a refresh rate. Every monitor will tell refresh rate, right? Normally 60 to 80 frames per second in raster scan. Random scan 30 to 60 frames per second, means you have to refresh before that, right? That is the frame buffer. Then that is what normally refresh, right? Then frame buffer location, that is the frame buffer, as I told, memory, that memory location, and the corresponding screen positions are referenced as Cartesian coordinates, right? Means frame buffer location, as I told, for example, you have reserved a memory for a frame buffer 0 to 100. 0th memory location of your frame buffer directly corresponds to 0,0 Cartesian coordinate pixel on your monitor, right? 0,0 pixel in your monitor, information is stored in 0th memory location of your frame buffer. Then 0,1 pixel of your monitor is stored in second, that is first memory location, because 1 is the first memory location, 0 is first memory location, then next memory location is 1, right? Then 1th memory location. Then 0,2th pixel information, 0,2th pixel information is stored in your frame buffer at second memory location, because you have started memory location from 0, right? That, like that, this is the meaning of this, that is frame buffer location, and the corresponding screen positions are referenced in Cartesian coordinates, right? Then what that refresh does, how it does refreshing, right? Then refreshing means, again you just recall random raster scan, how raster scan works. Raster scan always starts here, then comes right side, then goes back, comes next line, comes right, then goes back, comes next line, like this it comes at the bottom. Once it comes at the bottom, then again it has to go back to display the next frame. This is the operation of raster scan. Then for doing this one, these are called, when it is coming left to right, this is called scan line. It is displaying the information. When it is displaying information, only it is displaying information when that line is coming from left to right. It is doing nothing when it is going back. This is called vertical retrace. During vertical retrace, it is doing nothing. Only when it is coming from left to right, that time only it is displaying. If the particular information is available in particular memory location, then that particular pixel will be switched on. If the information is not available in the respective memory location of this pixel, then that pixel is switched off, right? That was doing. Then in this, that is called scan line. These are called scan lines, right? Then normally, again, as I told, our monitor means our device, this monitor origin is here, our monitor origin is here, right? Origin is top left corner, means 0, 0 is here, then this is x, this is y, right? X will increment right side, y will increment down, But normally whatever we will study in mathematics or whatever we have generally studied, we have taken origin here, somewhere here. Normally we will take origin somewhere here. There is no change in x. In our coordinate system also x was increasing right side, in monitor coordinate system also x is increasing right side. But there is a change in y, our reference point and monitor. Normally we will increment y upward. Normally we will increment y upward, but monitors will increment y downwards, right? That adjustment can be done in OpenGL. This can be changed, right? We will normally change. You can set origin anywhere, right? If you want, you can set origin here. If you want origin, you can set anywhere in your monitor. That can be done by using OpenGL commands in our graphics, right? If you take our reference, this is the origin, then this is y max. This is y max. If you take monitor reference, then this will be y max. This will be y max, right? Don't get confused. That normally whenever we are doing that conversion, we have to do. That conversion we have to do with y. Y means we have to adjust y, because monitor takes y0 here. Our reference takes y0 here, right? That conversion we will do whenever it comes. That concept I will tell in future videos, right? Then scanline are the labeled from y max. Scanlines are labeled from, because always it comes from like this. Always it comes from top. If your origin is here, then this will become y max. If you have taken origin of your monitor somewhere here, then automatically it will become y max, right? That's why it starts at y max at the top of the screen to 0 at the bottom, 0 at the bottom. Then along each scan line, this is a scan line, I have told this is a scan line. Along each scan line, screen pixel positions are labeled from 0 to x max. Then toward this side, since x is incrementing this side, x is incrementing this side, then what is x here? X is 0. Then next 1, 2, 3, 4. X will increment up to x max. X will increment up to x. Means this refreshing will be done by video controller always from the top left corner. That's what scan line is y max. First scan line number is y max, then y max minus 1, y max minus 2, y max minus, like this it will come to y0. That is 0. 0 is here. It starts from this side, then goes right. When it is scanning one scan line at that time, on every scan line only it keeps on incrementing x. It keeps on incrementing x. Those are coordinates, right? For doing this, for means we have to maintain which scan line we are refreshing on that scan line, which pixel in x direction, we have to monitor, right? Because in this scan line x is incrementing, again after this you have to come to next scan line, again x values may be same, but again x increments right side, again you have to come to next scan line, again you have to come to next scan line. Like this you have to start refreshing, means you have to drop. Refreshing means you have to drop scan line by scan line, because raster scan system works like that only. When we were discussing video device, that time we have discussed it, right? It comes here. Once it comes here, again it goes back like this. That's why to do this, here we have this system maintains 2 registers are used to store the coordinates of the screen pixels. We require 2 registers to store the coordinates of, because every time I want y, every time I want x. Y will tell which scan line, x will tell on that scan line which pixel. On that scan line, what is the pixel? That is means x comma y. We require always x comma y, right? That's why we will maintain this device. This system will maintain 2 registers are used to store the coordinates of each of the screen pixels, right? Then here there is a raster scan generator. It will generate the raster scan here, right? Raster scan generator will be there. Regarding this we will discuss in next slides, right? Then x register and y register. X register will maintain the x values on your monitor. Y register will maintain the scan lines y max to y0. Then memory address. Then nothing but what is this? This is the means x y values will be stored in particular memory address. That is what frame buffer, right? Normally I want to display my output on x and y, which is x and normally we will maintain x and y values on our monitor. Then raster scan will generate values with respect to x y. Those x y's we have to store in a memory in the same address, memory address. That memory address is a frame buffer, right? Then with respect to that memory address we have to store the intensity, means what is the color, right? Identify which pixel, then store it in a memory. Memory is nothing but a frame buffer. Then within that pixel what is the intensity, means what is the intensity, means nothing but what is the color. If it is a colored monitor, what is the color, right? That we have to store. Then whenever it is refresh buffer is taking the values, it goes to x and y. It takes the means x and y, it refers x and y, x and y in turn it will refer the respective memory location. As I told, if 0,0th pixel memory location is 0, raster scan will generate the value for 0,0, then 0,0 pixel will refer the memory location, 0th memory location in frame buffer. Then next 0,1, if raster scan generates the value for 0,1, then 0,1 pixel values will refer memory location 1 in the frame buffer like this, right? Then these x and y values will identify what is the intensity here. Again, intensity will be controlled by x and y values, right? This is how refresh. Then it comes line by line. It comes line by line. It takes the content from the frame buffer. Every time it goes to frame buffer, takes ymax value. Basically, initially scan line will be assigned with ymax, right? Then ymax starts. X is initially initialized with 0. X is initially initialized with 0. Then y is initially initialized with ymax. Comes ymax is nothing but top line. Here it will come here. Then it comes right. Every time x keeps on incrementing in this scan line. Then when x reaches to x max, it comes back. When it is coming back, it will decrement the y. Because you are at y max, you have to come next. Because your origin is here, then you have to come next below. That is y max minus 1. Then you will come here. Again x will be initialized to 0. Then again start x incrementing. Once x reaches x max in this scan line, then come back, again decrement y. Then nothing but you are coming to next scan line. Then again come right by incrementing x like this, right? This is what refresh. This has to be done. This is what means you are drawing. Means you are taking the content from the frame buffer. Then frame buffer 0, means you will take. Then respect to frame buffer memory location is directly corresponds to pixel in this. Then if content is there, then what color intensity is there, that with that content intensity you will illuminate. Then come next like this. This we are doing, right? Then at the end like doing like this, you will come somewhere here. Then once you come, we have displayed one frame. Then again you have to go back to here. Again initialize once you reach y0 and x max. Once you reach y0 and x max, again you initialize y with y max, x with x0. Right? What is the value here? Here value is, if your origin is somewhere here, your value at this point is y0 x max. Once you come y0 x max, again you have to go back here. How to go back here? Initialize again y max x0. Y max, again it will come here, again it will repeat. This is what refreshing. To do, why we want a additional video controller? Because in a given second, this has to done 60 to 80 times per second. Only displaying them on a monitor has to be done 60 to 80 times per second. Means 60 to 80 times per second, this entire monitor has to be displayed. Assume that 60 times, 60 times in 1 second. 1 second, 60 times you have to draw this entire screen. First time we will draw one time we will draw this screen, then next time we will draw next time we will draw same, then next time like this. How many times you have to do? One in 1 second. 60 times if you do, then only you will see that this content on this monitor is not flickering. Not flickering means you will not feel the content is going off. The content is going off. If you do less than that, then automatically what it does, you will get a flickers. You will get a flickers on your monitors. Right? You will get a flickers on your monitors. If you don't want to see the flickers on your monitor, then whatever refresh rate that device mentions, with that refresh rate minimum with that refresh rate you have to redraw. Refreshing is nothing but what? You are redrawing continuously. Right? See what is this is not, it is nothing we are doing, means there is no any calculation at all. Already output is there in a frame buffer. Take the content and display. Take the content and display. Such work, that's why such work will not assign to CPU. Such work will not assign. If you assign this work also to CPU, then other than the operating system management, it has to do this. Right? That's why we have the additional video controller. right? Only video controller takes this, means that additional work whatever in olden day systems CPU was doing, what work it was doing? Just redrawing. Already output is there, just to draw it on a monitor. That work you have taken from the CPU, then additional processor you have kept in your system, that is a video controller, right? This will video controller. Other than this, video controller does many works, right? Video controller, in if your refresh rate is very less, if your refresh rate is very less, you are not able to achieve the refresh rate of your monitor, right? Your processor refresh rate is very less, it is not able to match with display device refresh rate. At that time, what video controller does, instead of reading 1 pixel at a time, it reads more than 1 pixels. It reads in one cycle, it has a capacity of reading more than 1 pixels, right? In such way, instead of going and taking only 1 pixel content, go once, pick more than 1 pixel content, then draw here. Like that you can increase the speed, refresh rate can be increased, right? Like that other works also video controller does. This is basic operation does by your video controller refreshing. Then as I told, transformation. Again, transformation is nothing but what? As I told already, first image, first output you have drawn somewhere here. You take this as example. I have drawn this in this position, right? First time means whatever my display processor has done, it has displayed continuously. It is displaying somewhere here. Whatever refresh rate is there, continuously it is displaying. Means again I have told Y max it comes to Y max, goes X max, comes next, like this it was displaying. Then this is repeated. Then afterwards what I will do, I will take and drag somewhere here. Now I would like to draw this object somewhere here. Nothing but what I have done, I have moved my object place from this place to this place. Again, what my display video controller has to do, means whatever X, Y values were here, because this X and Y value may be different, this X and Y value, this here it has to do transformation. Here it has to do the means here X and Y value is different, here X and Y value is different. This transformation has to, means there is a calculation here. There is a calculation. This has to be done by display processor, because already your content is there in frame buffer. You cannot change the content of frame buffer. Then who has to do the content of, means you cannot do the content of content of frame buffer, right? Only you are taking the value from the frame buffer, you are displaying. But what I have done earlier, I was displaying, originally my program was displaying somewhere here, but by taking my mouse I have dragged and dropped somewhere here. Somewhere here is in the sense what? If X and Y is 20, 20 here, then X and Y may be 100, 100 here, 100, 100 here. Then who has to change this one? This calculation has to be done by video controller at that time. Video controller only has to do, because whatever content is there in the frame buffer, that content is with 20, 20, because already I have written program for 20, 20, right? That's why my frame buffer has the content of, with one example I am giving 20, 20, right? But using mouse I have dragged and dropped here, maybe 100, 100, right? Then 20, 22, now onwards my display device has to display at 100, 100. That calculation has to be done by my video controller. That is what transformation it has to do. Means again, sometime what I will do, I will scale, I will make it large, right? I may rotate, right? These all operations has to be done by video controller, right? These are the operations of video controller, right? How? Yes, that's why I told X and Y registers will maintain, then because the coordinate system. Then next is the display processor. Next is display processor. What display processor does, right? The purpose of display processor is to free the CPU from the graphics cores, right? Again, the purpose of these video controller and display processor is just to free the CPU. In olden days, these were not there. Every operation will be done by CPU. If you assign many operations to CPU, then automatically your CPU will be slow. To reduce the burden on the CPU, then speed up the CPU speed, now display processor, video processor came into picture, right? The major task of the display processor is scan conversion. Already I told, video controller is taking data from the frame buffer. Always video controller takes data from the frame buffer, then displays on the monitor. Then who is writing data on frame buffer? Who is writing data on frame buffer here? Right? Display processor takes data from the frame buffer and writes in displays on monitor. Then who has kept data in frame buffer? Right? That will be done by frame. That is display processor. The major task of the display processor is called scan conversion. What do you mean by scan conversion? Scan conversion is digitizing a picture definition given in an application program is the set of pixel intensity values for a storage in the frame buffer. Means normally user will give input in a geometric coordinate system, geometric format, right? Then that value has to be converted to discrete values. That value has to be converted to discrete values. That discrete values has to be stored in a frame buffer, right? That is what scan means. You have to digitize your input. We have to digitize it because I am given input. For example, for drawing a line, I will give 10, 10 to 100, 100. Normally, when you are drawing a line on my computer graphics application, what I will give? I want line from 10, 10 to 100, 100. Just I will give input this 10, 10 to 100, 100. Then what is 10, 10? Where that 10, 10 will come on my monitor? Where is 100, 100 in my monitor? That because 10, 10 I have taken imaginary. 100, 100 is my actual, means some Cartesian coordinate I referred. But where is 10, 10? Where is 100, 100 in my monitor? That is digitization. That you have to convert. Is digitize the picture definition given in the application program into a set of pixel intensity values for storage in the frame buffer. That's why display processor takes your input, whatever input you have given, raw input, then converts that into digital format. Converts that into digital means if 10 means somebody may tell 10, 10 will come here. Somebody may tell 10, 10 come here, because what unit you have taken to measure, that varies. When you are doing on pen and paper, at that time units may vary. That's why then actually where is 10, 10 on monitor? Because those are fixed, they will not change, right? Because gap between pixels is same, right? That's why that has to be converted. That is what digitization. That means this digital values are stored in a frame buffer. Then video controller will come into picture. Then frame buffer content video controller will take. Then it will display it in a monitor. Right? The display processor what does? It takes your input as a raw input, then converts into digital format, then writes into frame buffer. Right? Then how that does? Again, the system. If you see the system, IO devices here, display processor. Display processor will come. It takes your raw input, whatever you have given, then that will be converts into digital format, then that will be returned to frame buffer. Then from frame buffer your video controller takes the input, then draws it in monitor. Right? This, for example, interface with again here display processor takes your commands from the commands, whatever command you have given in OpenGL. As I told you, draw a line. You are given one command, simple one command I am telling, draw a line from 10, 10 to 100, 100. You just simply are given draw a line 100, 10, 10 to 100, 100. Then that 10, 10, 100, 100 is taken. Then where is 10, 10? Where exactly 10, 10 comes on monitor. Then where 100, 100 comes. Then in between that again only you have given 2 points. You have given starting point and end point. But when it is drawing a line, if 10, 10 is here, 100, 100 is here, then what about intermediate pixels? Who has to calculate the values of intermediate pixel? Those has to be calculated. Again, there are algorithms, scan conversion algorithms will be there. Those will be used. Then it will convert that input, raw input into digital format. That will write in a frame buffer. This is a frame buffer. Then already for example, if you have drawn house, you have drawn program, you have written a program for drawing a house. You have given some values for drawing. Then that has to be converted. Then those values has written here. Then already your output is here. You see your output is here. Right? But it is not on monitor. Then who will write on monitor? Video controller came into picture, then takes input from the video controller, then it writes on your monitor. This is your monitor. Right? Like this it will do. Right? That is what digitization. Right? Then this is right. Then random scan system. How random scan system will work? Random scan system, graphics commands are translated by the graphics package into a display file stored in the system memory. As I told, random scan takes input from the random scan. Display processor will take input as a program. Then that input will be executed. That program will be executed every time. Then that program, whatever program output comes, that will be displayed on the monitor. Right? This file is then accessed by the display processor unit. Right? Here before this, input to display processor was again a program, right? That program will be converted here, then that output is written here, right? This file is then accessed by the display processor unit, DPU, graphics controller to refresh the screen. Now in this case, here directly in random scan, display processor takes the input from the memory, then converts. Here you don't require the video controller here. You don't require the video controller because directly your display processor is taking the system memory. What is system memory here? System memory contains your program. System memory contains directly program. Then whatever program generates output, that you are going to display it in a monitor, right? That's why this file is then accessed by the display processor unit and controls the refresh. That means refreshing, everything will be done by display processor now. In random scan, everything means converting into discrete format, then displaying on the monitor will be done by display processor, done by display program directly, right? Then random scan system. That's why random scan system, display control, that is a DC, your input is here, then in your memory program will be there directly. But in previously the output was here, right? Then video controller is taking this output, then it was displaying. In this case, everything will be done by your display processor, display controller or display processor. Takes input from the display list. This is called display list. Normally here we will call a frame buffer. Here we will call a frame buffer or refresh buffer. But in this case we will call it as a display buffer, right? Then programs will be like this: draw 200, 200, move 200, like. Then this will take program as an input, then directly converts. When display processor itself converts into discrete digitizer, then it only display controller itself displays on the monitor. There is no video controller. There is no video controller. Directly both operations will be done by display controller in random scan, right? This is how the random scan system or raster scan system will work, right? Thank you.